So that's a quick walkthrough through the worksheet. You will again get your own copy of this repository from GitHub Classroom. I'm going to take this copy here. There are two tasks. The first task is to now generate some configuration checker for PCs. There are some hardware components and some additional constraints, and you have to generate an SMT formula and solve that SMT problem to see what components you can configure based on some budget. So here are some details. So all the code that you need to write starts in this one method here, in the create config formula, and this method basically needs to assemble an SMT formula, and now it needs to do that based on some PC configuration problem that it reads from CSV files. So the CSV files, they have some components where they're categories and prices, and they are in two CSV files basically, but there are some helper functions that can read those CSV files for you. We will have a look at them. So one is the components, and the components, they're all the first, that's the kind of component, and then the second column, that's the component name, and the third column, that's the price of the component as an integer. And then we have some constraints. So constraints, they're always of either requires type or excludes type. Requires type means that the one on the next column requires the one on the last column. So here an i3 would require the Gigabyte Intel mainboard. i7 would also require it. Ryzen 7 might require the MSI AMD. So these are component names from the previous list. And that's what the requires means. The one on the left always requires the one on the right. And excludes basically goes in both directions. So if you have an RTX, you cannot have the GTX. And if you have the GTX, you cannot have the RTX. So now, yeah, how are you going to read those? I cloned the repository already and opened it in VS Code. The CSV files, that's the same here, same as we have in the repository. The README is also here with the instructions. And then there's some source code here. So we have the main file, which is the PC config generator and solver. And we have the PC config reader. So the reader reads those CSV files here, has some helper methods. One to read the components based on a given category, and one to get the constraints based on a constraint type, and the constraint type is only requires or excludes. Whereas the components, they're also listed in the main method, and the main method is here. So those are the kind of components: CPU, motherboard, RAM, GPU, storage, optical drive, cooler. Those are the ones you need to handle. You could, of course, write some generic code that would handle any type of components, but those are the ones that we're going to use here. But what might change is the number of components and their prices and their names inside these CSV files, right? So the categories here, CPU, motherboard, those are the categories that we also see in the main file, CPU, motherboard. Here we're just printing the components. So this print components basically reads them from the CSV file and then prints the available components for each category. And the second one here prints the constraints of the requires type and of the excludes type. And then we have some helper code that asks to enter a budget, then you put a budget and the program continues. So let's simply run this. We're now going to run this, and it's going to print the available components. So that's what's happening here, available components. And then first it prints the CPUs. So components of type CPU are these. Then it prints the ones of motherboard. And this should match, of course, the ones in the CSV file. And you can expect that the CSV files, we might change them for the test cases, right? And your solution should be generic in the sense that it can take any kind of CSV files that have the fixed set of components, and the products they can change and the prices they can change. But that's not all. So there are some additional constraints here. They're described in the README, that every valid PC needs at least one component of each of these categories, CPU, motherboard, RAM, and storage. Of components of other categories are then optional. So the ones that we saw here, maybe optical drive or cooler, this would be maybe an optional one. But of course, they could be required by the constraints. And the users provide some budget on the console. That's already implemented here. So here it asks us for some budget. Let's say for, I don't know, 1,000 euros or whatever budget that is. Then it tells us it's searching for some configuration, but it doesn't do anything because right now we're not generating any formula. So that's the part written in the README file where you need to create this config formula. And we're using JavaSMT. So as you could see in the tutorial video that is also linked here, you need this Boolean formula manager to create the formulas. You need the integer formula manager to create formulas with arithmetic. And then we have this budget. So basically this method here, let's try to find it. That's the create config formula. That's the one where it says to do implement the translation to SMT. So you're basically going to use the helper methods. Let's see, in print components, it uses the PC config reader get components of some type. So you're going to use this get components method to iterate over the kind of components. You're going to use the get constraints method to read the different kinds of constraints. And then based on what results these return from the CSV files, you're going to create formulas that encode the configuration problem. So yeah, these are the methods. You don't have to understand how the methods work. They basically just read the CSV files. They're also not that complicated. And then your work will basically be in this method. Of course, you might want to create some helper functions for some of the more complex subformulas that you need to add. Here, yeah, you probably want something as the parameters of this end here, right? Probably you're going to create some conjunction of some constraints. Yeah, that's the task one. So in task one, you basically have to generate that formula, and then it will print the selected module, selected model, or it will tell you that no solution exists. So only changes are required here. And then for task two, what happens is that we are asking you to also do the redundancy analysis. So to assess the quality of the code that you're generating, here you're generating some kind of formulas, right? And maybe these formulas have some redundancies. So that's one way to look at quality aspects. One way is looking at redundancy. And we're asking you to do this. So when you run the test cases, you can do that again. Yeah, simply with the integration. This is now running the test cases in the VS Code integration, but of course you can also do that with the Gradle tasks. So you have the verification test task, and that's the same thing as running it on the console. So these are just different ways to run the test cases right here. And they're failing right now for obvious reasons because I didn't implement anything yet. We could get a new terminal and then yeah, we can do a clean and a build. And the build will of course always run the test cases as well. So then yeah, again, we have failing test cases, and it says here why. So for there's one test case which also generates multiple files. So here's this test case that generates some, which one is it? Yeah, some different budgets, and it dumps the formulas. So for these different budgets, you will see the formulas being printed. and they'll be in a folder. Let's have a look at the README file. It says there should be a folder called task2. Maybe we need to. Maybe that doesn't work yet because it can't. This one would fail here. This one tries to generate. Maybe it's not generating them yet. I'm not sure where they should be, but they're not here, right? So maybe they will be here once you correctly implement these parts. Then they might be in this folder task2 that will be created for you, and then you'll find the different formulas, and you can check them for redundancy in the playground. So here it's asking you in this task2 folder, then you analyze them for redundancies in the playground. So it will have one formula or one SMT lib script for each budget. Those are the different budgets that it uses to create them. Then we're asking you to reflect on the results of the analysis, write some short summary in this explanation text file that's also in the task2 folder, and then decide whether you want or how you should change your formulas, maybe to generate less redundant formulas, or argue why that's probably not a good idea. So that's the two tasks of the worksheet. And again, you will have the bar here and the feedback report generated for you.